Right, hello you lot, and welcome to the first Big Science Goes Global video. Right, now there are these numbers, okay, some of them we're more familiar with than others, right. Suppose I wanted to make an egg sandwich. So I've got my half dozen eggs, and I've got my, I don't know how many slices of bread, right, and I've decided that what I want to do is to have one egg for each two slices of bread. So I get my egg, boil it, chop it up, stick it between two slices of bread. I'm then going to need, if I want to make half a dozen egg sandwiches, I'm going to need half a dozen eggs and a dozen slices of bread. 2, 4, 6, 8, 10, 12. So, a dozen slices of bread, half a dozen eggs. So, in order to know what I need to do, I say I want a dozen egg sandwiches, then I would want 2 dozen slices of bread and a dozen eggs. Okay, so when we say dozen, what we're doing is we're expressing how much of something there is. And there are other numbers like that. One of them is another words like that. For example, another one is myriad, which refers to 10,000. And then there are the Indian words lakh, which is 100,000, and crore, which is 10 million. And then there are other words in the duodecimal system, such as dozen, gross, zagier. Zagier is a cube dozen. Now, sometimes we need to refer to extremely large numbers because the objects we're talking about are very small. And one of those words for numbers, which can be used in recipes, i.e. chemistry, is mole. Now, the word mole refers to the number 6.02214179 times 10 to the power of 23. Here it is on the screen. Right, that's a big number. It refers to the same number of objects as there are atoms in a pure sample of carbon-12. Now, that's a very large number. It's 600,000 million. Okay, now how much is that in realistic terms when we're talking about atoms and molecules? Well, what you have to do is you have to look at the weight of the atom or the molecule concerned. Now, in the case of water, there's oxygen 16 with an atomic weight of 16, and there's hydrogen, protium, with a weight of 1. Now, the formula for water is H2O. Therefore, a mole of water will weigh 16 plus 2 grams, or 18 grams. Now, it so happens that it's standardized on that weight, so this is a mole of water. Hopefully you can see that that's around 20 mil. It's not very much at all. Let's take another example. Let's have a mole of sodium chloride, or salt. Right, now a mole of salt consists of sodium and chlorine. Okay, so that's sodium with an atomic weight of 23, roughly, and chlorine with an atomic weight of 35.5, roughly. Now, if you add those two together, you will get a weight of approximately 58 grams. So this is going to be a mole of salt. Here's my container. I'm going to put on there. And a mole of salt is 58 grams, so 8 grams, roughly. So that, which is fluctuating a lot, that is a mole of salt. Okay, now, what about a mole of air? Well, obviously it's a mixture, so we're going to have to assume it's oxygen and nitrogen rather than anything else, and I will show you how much a mole of air is. It's approximately 22 litres, which is this much. Right, so that's equivalent of a mole of nitrogen or oxygen. That's N2 or O2. That's a mole of salt, and that's a mole of water. And the situation is that when you're doing a recipe, like egg sandwich, same thing, reactions in chemistry are a recipe, and you need to have the right quantities, and it's expressed in moles. And all a mole is a number. It's a very big number of very small objects, but it could be used for anything. You could say a mole of oranges, which is about the size of the Earth. Not going to happen, but it can be done.